Today's daily LeetCode problem of the day is minimum cost to convert a string, part 1, number 2976. For this problem, we're given a zero index string source and target. Both are length n, and they consist of lowercase English letters. We're also given two zero index character arrays, original and changed, and an integer array cost, where cost of I represents the cost of changing the character original of I to the character changed of I. So this is confusing, so let's look at the example real quick. So we have our input string source. We have our input string target. We have an input character array original and an input character array changed, and then cost. So original, changed, and cost are all three linked together. So if we look at index 3, so 0, 1, 2, 3 of original, it's a C. If we look at 0, 1, 2, 3 of changed, that just means that C at index 3 can be changed to E at index 3 on changed for a cost of 0, 1, 2, 3, 1. So we're going to start with our string source, and in one operation we want to pick a character from the string and change it to another character at the cost of z, if there exists at any index j such that cost of j is equal to z, original of j is equal to x, and changed of j is equal to y, which basically just means that the cost exists, the original character exists, and the changed character all exist. We want to return the minimum cost to convert the string source to the string target using any number of operations. If it is impossible to convert, we will return -1. We also need to note that indices I and j may exist where they're also equal to each other. So that means there could be duplicates. So there's two C's in original, there's two B's in changed. So we want to find the minimum points or cost so we can allocate it when we need to make that change. So for this input example, the output is 28. Why is that? So we're going to convert our string ABCD to ACBE. So we're first going to change index 1, so that's B, to C in our target. That's going to cost us 5, because if we look at our original array, B only appears once. So that's going to be index 1. So if we look at index 1 of change, that is C. If we look at index 1 of cost, that is 5. So to change B to C, it's going to cost us 5 points. So we add 5 to our total. We then do this for each letter until we reach our target letters or string, and then we're going to return the cost that we incurred. If we can't find the right output, we return -1. So this is very similar to yesterday's problem. We are going to use the Floyd-Warshall algorithm, and that algorithm basically finds the smallest path from one point to the next in a graph. So to solve this problem, we are going to make a graph. The graph is going to be of 26 by 26, so we're going to map each letter, and the path to take from one letter to the next, we're going to allocate a cost. So this problem is going to be broken down into 6 steps in our main function. We're going to initiate an infinite variable, initiate our 2D matrix, then we're going to initialize that matrix, filling it with values. We're going to then populate the matrix with our given information. We're going to use our Floyd-Warshall algorithm to find the smallest path between two characters, and then we're going to calculate the total cost it would take to change our string from source to target. So let's start with initiating our infinite variable. So integer infinite is going to be equal to an integer, and we're going to have it as 1e9 plus 7. So basically infinity. So why are we initializing this as infinite? Later on in our calculation function, we are going to check if our cost is equal to infinite. That means we can no longer build the string, so we're going to return -1. So that's all that infinite variable is there to do. It's there to be a placeholder. We're then going to initiate our matrix. So integer array matrix. It's going to be equal to a new integer double array. And these are both going to be of length 26. So we're going to have 26 rows and 26 columns because there are 26 letters in the alphabet. Let's now initialize the matrix. So for int I is equal to 0 as long as I is less than 26, we do I plus plus. So to initialize this matrix, we're going to fill each variable with each spot with our infinite variable, except for the character itself. So if the character in the matrix, so let's say matrix of I, the path from a character to itself is going to be equal to 0. If it's not equal to itself, we're going to fill, so arrays.fill, matrix of I, so the entire row, to infinite. And then we change from one character to itself to 0. We can now populate the matrix with our given transformations. So for integer I is equal to 0, as long as I is less than our original dot length, I plus plus. So that is our character array original. We're going to go through each one of the characters in original and find its correlation in changed, and then mark down that spot in the matrix. So original of I and changed of I will be equal to cost of I. So integer from will be equal to original of I minus A. This will simply just turn whatever letter this is into a 1, 2, 3, 4, or 5. So if we have A here minus A, that will be spot 0 in the matrix. Integer 2 will be equal to changed of I minus A. Now we could fill the spot in the matrix. So matrix of from 2 will be equal to math.minimum matrix of from 2 or cost of I, whichever one is smaller. So why are we using math.minimum here? Because there can be multiple occurrences of the same letter. So for example, in original, there are 2 occurrences of C. We want to find whichever one has the smaller cost. So in this original array, 0, 1, 2, and 3 are both equal to C. So 0, 1, 2, and 3 are not equal. So we don't necessarily need to do it in this example, but if both of these change values were B, for example, we would find 0, 1, 2, and 3. We would pick the 1 because that is the smaller variable, or the smaller cost. In this example, however, the C's do not correlate to the same character, so they will be mapped in different spots. We will then call to our Floyd algorithm, so Floyd, and we're going to pass it the length of our 2D matrix, so that's 26, and we're going to pass it the matrix itself. So let's go ahead and build this algorithm. We're going to have a private void Floyd, rhymes, with an integer n and an integer 2D array matrix. So, what is the Floyd function? It is a triple nested loop. The triple nested loop is going to look for the smallest path between 2 characters. The smallest path is either going to be directly from one character to the next, or it's going to go from one character to an intermediate character, then to the final character we want to achieve. Either way, it is looking for whichever path is going to have the smallest cost. So let's initiate this triple nested loop. So for integer k is equal to 0, as long as k is less than n, k plus plus. K is going to be our intermediate value. That's going to be the character that could be a smaller path from one character to the next. So for int I is equal to 0, as long as I is less than n, I plus plus, that's going to be our from value. And for int j is equal to 0, as long as j is less than n, j plus plus. That is going to be our to variable. So if matrix of I of k is less than sorry, this isn't necessary. So in our Floyd-Warshall algorithm, we simply just need to go and find the smallest path, which is going to be our matrix of I to j is equal to the math dot minimum value of matrix of I of j, so whatever value is currently stored there, which will initially be infinite. So it's either whatever value is currently stored there or matrix of I to k plus matrix of k to j. So whichever has a less cost. And that is it for our Floyd algorithm. That will find the smallest cost for each instance of I to j. Then we are going to calculate the total cost it's going to take to change from source to target. We're going to create a new function for that, and we could call it, we're going to return total cost. We're going to pass it a couple variables. We're first going to pass it our string source. We're going to pass it our string target. We're going to pass it our matrix and our value infinite. That is going to help us determine whether or not we have a valid output or not. So we're going to have a private, it's going to return a long because that is the variable type we want. So private long total cost. It's going to receive a string source, string target, into the integer array matrix, and an integer infinite. So how do we calculate the total cost? All we have to do is do a for loop, traverse source, look at the original character in source, whatever the original character is. For this example can be A. Whatever that position is, we'll look at that variable in target. And then we look at our matrix and plug in the source of I and the target of I into the matrix and find that cost. If that cost is greater than or equal to infinity, we're going to return -1 because there is no path from source of I to target of I. Otherwise, we will update our cost based off of whatever variable is there. So we have a long output, which is going to be equal to 0 for int I is equal to 0 as long as I is less than source dot length I plus plus. We're going to look, so we're going to have our two characters. Character OG is going to be equal to our source dot char at I, and our char changed is going to be equal to target dot char at I. Now to update our cost. Our integer cost is going to be equal to matrix. Sorry, so we're going to update our cost, and our cost is going to be equal to matrix of OG, so whatever is at OG, and then we're going to subtract A, so we could get the numerical value, to our change variable, minus A, to get the numerical value. So that is our cost variable. Now, if cost is greater than or equal to infinite, then we're going to return -1. There is no path from OG to changed. Otherwise, our out will plus equal cost, and then we can simply return out. So if we run this, passes our test cases, and if we submit it, passes all solutions. Now let's do this in Python. So this will be pretty much the same in Python. We're going to have our variable infinite. It's going to be equal to an integer, which is 1e9 plus 7, or infinity. Then we're going to have our matrix, which is going to be equal to infinity for each variable in 26 rows and 26 columns. So for underscore in range 26. So 26 rows, 26 columns of just infinity. Then we populate it. So for I in range 26. Matrix of I is going to be equal to 0. So the path from a character to itself is 0 at all times. Then for I in range, length of original, we're going to do a from index, which is going to be equal to order of original of I minus ord of A. So in Python, ord simply returns the Unicode value. So it's going to return the Unicode value of this character minus the Unicode value of A. So it's going to be equal to like between 0 and 26 and 25. Then we're going to have our to index, which is going to be equal to their numerical value of changed of I minus their value of A. Then we can populate matrix, so matrix of from index to index will be equal to the minimum of what is already there, so matrix of from index to index, or the cost of I. So that will populate our matrix. Then we can call to our Floyd algorithm. So Floyd, and we're going to pass the length of our matrix and the matrix itself. So let's go ahead and define this function. So define Floyd. It's going to pass self, integer, n, and 2D, just n, and matrix. So our Floyd function is going to be the triple nested loop once again, so for k in range n, or I in range n, or j in range n. Matrix of I of j will be equal to minimum of matrix of I of j, or matrix of I to k plus matrix of k to j. And that's it for our Floyd function. We're then going to return self dot cost. We can just let's call it cost find. So we're then going to return self.costFind, and costFind is going to take in source. It's going to take in target. It's going to take in our matrix. It's going to take in our infinite variable. So let's go ahead and define this function. So define costFind, self, source, target, matrix, infinite, and all we have to do is initiate our total cost to 0, and then for I in range length of source, we're going to have our OG character, which is equal to source of I, our change character, which is equal to target of I, and the cost will be, the cost will be equal to matrix of value of our original minus the value of A to the value of changed minus value of A. This should be parentheses, not brackets. Then we simply need to check if the cost is greater than or equal to infinity. We return -1. Otherwise, total cost will plus equal cost, and then we can return our total cost. We run this, passes our test cases, and if we submit it, passes all solutions. Thank you, and follow for more daily LeetCode solutions.